You got to have all the things necessary to sustain civilization on Mars. And the reason that the ships from Earth stopped coming could be World War III, or it could be due to a slow decline of civilization.
Mars has been a source of wonder and speculation for generations. As our closest planetary neighbor after Venus, Mars has long been the subject of scientific study and popular fascination. Its similarities to Earth have led many to wonder, could we one day call Mars our second home? Let's start by getting to know Mars a little better. This planet, named after the Roman god of war, is roughly half the size of Earth and has a thin atmosphere composed mainly of carbon dioxide. Despite its smaller size, Mars boasts some impressive features, including Olympus Mons, the largest known volcano in our solar system, and Valles Marineris, a canyon system that would stretch from New York to California if it were on Earth. But what really makes Mars stand out is its potential for harboring life, both in the past and possibly in the future. The presence of water ice at its poles and evidence of ancient riverbeds and lake basins suggest that Mars once had liquid water on its surface. This tantalizing clue has fueled our curiosity and driven numerous missions to explore the planet's surface and atmosphere. One of the most exciting aspects of Mars exploration is the search for signs of past or present life. While we haven't found any little green men running around, scientists have discovered some intriguing possibilities that keep us coming back for more. NASA's Curiosity rover detected organic molecules in rocks that are billions of years old. These complex carbon-based molecules are the building blocks of life as we know it. While their presence doesn't prove that life existed on Mars, it certainly raises some interesting questions. Could these molecules be the remnants of ancient Martian microbes? Or are they the result of non-biological processes? More recently, scientists have detected methane in the Martian atmosphere. On Earth, methane is produced by both biological and geological processes. The presence of methane on Mars, which seems to fluctuate seasonally, has led some researchers to speculate about the possibility of microbial life existing beneath the planet's surface. But finding life on Mars isn't just about satisfying our curiosity. It could have profound implications for our understanding of life in the universe. If we discover that life evolved independently on Mars, it would suggest that life might be more common throughout the cosmos than we previously thought. On the other hand, if we find that life on Mars and Earth share a common origin, perhaps through the exchange of material via meteorites, it would still be an extraordinary discovery. Now let's shift our focus from the search for existing life to the possibility of creating a habitable environment on Mars, a process known as terraforming. Terraforming Mars is the stuff of science fiction, but it's also a concept that scientists and engineers have seriously considered. The basic idea behind terraforming is to transform Mars' environment to make it more Earth-like and capable of supporting human life. This would involve several major changes, including thickening the atmosphere, raising the temperature, and creating a planetary magnetic field to protect against harmful radiation. One proposed method for terraforming Mars involves releasing greenhouse gases to warm the planet and thicken its atmosphere. This could potentially be achieved by directing comets or asteroids rich in ammonia to impact Mars, or by manufacturing powerful greenhouse gases on the planet's surface. As the planet warms, it could release carbon dioxide trapped in its polar ice caps, further thickening the atmosphere. Another crucial step would be to create liquid water on the surface. As Mars warms and its atmosphere thickens, the ice at its poles and in underground deposits could melt, potentially forming rivers, lakes, and even oceans. This water would be essential for supporting life and could help to regulate the planet's climate. However, terraforming Mars is not without its challenges. The process would likely take centuries or even millennia to complete, and it would require enormous resources and technological advances. While full-scale terraforming might be a distant dream, the idea of establishing human colonies on Mars is much closer to reality. Several space agencies and private companies are already developing plans for crewed missions to Mars, with the goal of establishing permanent settlements on the red planet. The first Martian colonies would likely be small, enclosed habitats that provide a controlled environment for the astronauts. These habitats would need to protect inhabitants from the harsh Martian environment, including extreme cold, low atmospheric pressure, and high levels of radiation. They would also need to be self-sustaining, with systems for recycling air and water, growing food, and generating power. One of the biggest challenges for early Martian colonies will be resource management. Transporting all necessary supplies from Earth would be prohibitively expensive, so colonists will need to learn to live off the land, a concept known as in situ resource utilization. This could involve extracting water from the Martian soil, using local materials for construction, and even producing fuel for return trips to Earth. Another crucial aspect of Martian colonization is the psychological well-being of the colonists. Living in an isolated, confined environment millions of miles from Earth would be mentally and emotionally challenging. Colonists would need to cope with the stress of their dangerous environment, limited personal space, and the knowledge that they might never return to Earth. Before we can establish colonies or search for life on Mars, we need to figure out how to get there safely. The journey to Mars is no small feat. It's a trip of about 140 million miles, 225 million kilometers at its closest approach to Earth. This vast distance presents numerous challenges for human spaceflight. First and foremost is the issue of time. Using current propulsion technology, a one-way trip to Mars would take about 6 to 8 months. During this time, astronauts would be exposed to high levels of cosmic radiation, which could increase their risk of cancer and other health problems. They would also experience the effects of prolonged weightlessness, including muscle atrophy and bone loss. To address these challenges, scientists and engineers are working on various solutions. One approach is to develop more powerful propulsion systems that could shorten the journey time. Options being explored include nuclear thermal propulsion and plasma engines, which could potentially cut the travel time to Mars in half. Another area of focus is radiation shielding. Researchers are investigating materials and designs that could better protect astronauts from harmful cosmic rays during their journey. Some proposed solutions include water-based shields, electromagnetic fields, and even habitats built into the Martian soil to provide natural radiation protection once on the surface. The psychological aspects of long-duration spaceflight are also being studied. How will a small crew cope with being confined in a spacecraft for months on end, knowing that they're getting farther from Earth with each passing day? NASA and other space agencies are conducting experiments on Earth to simulate these conditions and develop strategies for maintaining crew mental health during extended missions. Now let's imagine we've overcome the challenges of getting to Mars and establishing our first colonies. What would daily life be like for the intrepid Martian settlers? Living on Mars would be an experience unlike any other, filled with unique challenges and extraordinary experiences. First, let's talk about the basics. Breathing. The Martian atmosphere is about 100 times thinner than Earth's and consists mostly of carbon dioxide. This means that any time spent outside a pressurized habitat would require a spacesuit. Even inside the habitat, careful management of air quality would be crucial. Systems for recycling and purifying air would need to operate flawlessly to keep the colonists alive. Water, another essential for life, would be a precious resource on Mars. While we've discovered water ice on the planet, accessing and purifying it for human use would be a constant challenge. Colonists would need to be experts in water conservation and recycling, making every drop count. Then there's the issue of food. While some supplies could be sent from Earth, a sustainable colony would need to grow its own food. This would likely involve hydroponic or aeroponic systems in controlled environments. Colonists might find themselves tending to crops of nutrient-rich plants like lettuce, spinach, and potatoes, much like Mark Watney in The Martian, but hopefully with better results. The Martian day, or Sol, is about 40 minutes longer than an Earth day. While this might not seem like much, over time it could affect the colonists' sleep-wake cycles. They might need to develop a unique Martian schedule to stay in sync with the planet's natural rhythm. Gravity on Mars is about 38% of Earth's gravity. While this would make some tasks easier, it would also present health challenges. Colonists would need to engage in regular exercise to prevent muscle atrophy and bone loss, much like astronauts on the International Space Station do today. What aspect of Martian colonization excites you the most? Do you have any questions about the challenges we discussed? Enjoyed this video? Then make sure you're strapped in for all our future cosmic explorations by hitting that subscribe button. And don't forget to tap that bell icon.